Hello, this is Jeff, and I'm going to show you how you can take a standard, what was called a paperclip motor back in the day, and use an Arduino and an H-bridge to run the paperclip motor instead of using the battery. So the standard paperclip motor basically takes a wire from each side of the battery and forms a cradle over the battery, over the magnet, excuse me. And then you take a coil of wire that's coated, basically inductor wire or transformer wire, and you have to polish it or scrape off the enamel so that the one side is completely bare and the other side just one half, as you can see here, just the one half. So if you place the coil, once it's balanced properly, as you can see, it's not a little bit crooked here, so it should be fairly straight and balanced. And if you place that in the cradle, and with a little help, it should spin. Because of the battery energizing the coil, causing basically making a magnet. So instead of using the battery, we're going to disconnect the wires and connect it to the Arduino. This is one from SparkFun, and we have a standard H-bridge, an L293D, and lesson 15 Arduino from Adafruit describes this circuit if you want to find out more about it. But basically the H-bridge is enabled by two pins, pin number 9 and 10 on the Arduino, and also pin 11 goes to pin 1, which is the enable, controlling the speed. The speed is determined by this potentiometer, so voltages from 0 to 5 are converted to 0 to 1023 bits of or numerical value divided by 4, and it provides the PWM output that goes to pin 1, which then controls the speed of the motor. The push button goes to pin 7 on the Arduino, which determines the direction. So the two enable pins on the H-bridge, depending on the polarity, determine the polarity on the motor. So here we have the two wires, pin 3 and pin 6, that form the voltage, and we can hook up a standard motor so you can see how that works. So I'm going to hook up just a standard motor to pin 3 and 6, and you can see it running, and I can control the speed, faster or slower, it's kind of hard to see, or I can change the direction by hitting the push button. So you can kind of see the direction changing, sort of kind of hard to see as I push the button. If I increase the speed, you can hear it, and here's the speed reversing. So I can take the same idea, apply it to my handmade motor, and remove the wires from the battery with this rubber band here. Okay, and then I take the pin 3 from the H-bridge chip, pin 6, okay, so you can see I'm bypassing the battery. Okay, we make a little bit of adjustment here to my motor holder. And my motor is a little bit mangled, so I need to adjust it slightly. If I lay this in the cradle now, you can hear the motor spinning. And if I get this a little boost, we should be able to see this going as well. Okay, so I'm going to pull the regular motor, well, I'll just leave it on here. Slight adjustment. I think the problem is I don't have a good electrical connection over here. Ah, there we go. Slight technical problems here. Okay. That noise was the H-bridge kind of shorting out because of the dead short that this puts on the circuit. But it should spin. Ah, there it goes. So it's spinning. Let's see if I can reverse it. There's a reversal. If it doesn't fall apart here, oops. I should be able to also control the speed. And here's the motor slowing down. And see if I can make it reverse. And there's the motor reversing one direction and the other direction. And the motor's also spinning. And there you have it.